And poke. Okay. So we're just going to cheat and use one of these as our daily quiz. .4 is there. Okay, that would technically be the 6th day that you've done stuff like this. Okay, which format is it in? They give me rate, a starting amount, a total, an example input output. Whatever they give me determines what my equations are going to look like. Might be really overthinking something. The equations are not big. Maybe.
I feel real dumb, but speed money. So like I was gonna like do like the what
Did you define your variables?
that's what I was gonna try to do now. Like
Where do we look to define our variables?
that question.
I can't give you much more than that. You got to show me what you know.
Okay.
And that goes same on tests. If you're a little confuzzled about a thing, you can ask me questions. I might just ask you questions in return and hope that it leads you down a path. That's all we can do. But just walking around, it looks like most of us, we got this. It looks like I see our last few finishing up. Give you about a minute to finish it off. Oh, if there's someone who didn't get your last set of notebooks and stuff back, there's a random paper of a couple of daily quizzes right there behind Noah's head. Didn't have a name on it. It was just kind of left on the floor. So if you're someone who just tore stuff out of a notebook, you might want to go put your name on that so you can actually get credit for it. Force is strong with that one. All right, don't overthink these. Start by defining your variables. Your variables are the things that they're asking about. So you go to the question at the end, how many copies of the newsletter must be sold to break even? So they're asking copies of thing. Copies of thing determines break even. That sounds like a input output X Y independent dependent. So this is copies of what? Looks like a newsletter, okay? To break even on what? Break even on the number of turtles I have? Money, okay? So you're right that both of those equations had to deal with money because they both had a y in them. So, all right, I got my variables labeled. How many copies of, so I need to solve for x by the end of it. And it says, printing a newsletter costs $1.50 per copy plus $450 in printer's fees. As a single sentence, did they just give me a rate, a starting amount, a total, or an input output? A rate, because they got per in there, and a starting amount. They didn't give me a total. They said, you got to pay this just to get it printed, and then this much per copy. So y is $1.50x plus 450, should say. So that's gone. The question we already dealt with. The copies are sold for $3 each might look like it's missing information because it's a very simple equation. It's $3 per copy that you're selling them. So your money is $3 per copy of the book. No extra. It's not like you got to pay $10 to get in line and then $3 per book you're buying. It's just straight up $3 per book. So this is set up real well for substitution. If y is this stuff, I shall replace y with stuff. So 3x is 150x plus 450. Subtract, play the who's lonely game. I'd get $1.50x is 450. I'll divide and get x is 300. Plug it back in. So at the end of this, because I labeled my variables, I can say that if I sell 300 copies of my newsletter, I will break even at $900 because that's how much it costs to print that many things. So, our points. Did you define your variables? I'm going to keep pounding on that drum. We have to do that. Otherwise, it's the first thing. It's not anywhere in the normal solving process. Every textbook I've seen all the way back through Algebra 1, they just kind of gloss over that and just start writing it. So make sure you do that. Yeah?
What if I define them just kind of wrong?
Further. What do you mean?
Okay, so I did, for my things, I did money spent is your X and money made is your Y.
Okay, so
I defined it.
just be one off. I saw your equations were right. We were just a little fuzzy on what they meant.
Yeah, I just knew they were both money. I just didn't know
Okay.
what it was. So
It would just be a one-off if you got everything else, 4 out of 5, yeah. Did you write both of your equations correctly? You know what? Actually, I'm going to do that as a double dose. 2, did you write each equation correctly? And then 1 for your work to solve, because who knows what you did there. Did you get to the final answer? Okay. So,
what if I did y equals 3 and I just forgot the x, but I did everything else right, and it would have been right if I had the...
it just plain said y is 3?
Yeah.
Oh, sad face.
If I would have
You ran it all the way to the end zone. You just went to the wrong end, Forrest.
Yeah.
4 out of 5, yeah. Okay. Yo, that same as on your tests. That's what I want you to do. Asking a question like that. A couple of you have come in and looked over tests with me, and okay, I know that I got it wrong here. I don't know what I did wrong. And we go through the problem. A lot of facepalm action. Okay? Usually it's a 4 out of 5 on the question, unless you're just completely out in left field. So, 5 things, 5 points. While we got it up here, anything from the homie work? 13? Okay. Bump. Mm-hmm.
Sorry.
12?
Yeah, 12.
Okay.
Yeah.
Something about kayaks. Okay, this is our current problems that we were talking about, where you're going to have your speed plus something speed, whether it's the river. That looks really creepy in inverted colors. Like the river of blood. Or lava, like every little kid has played the jumping on furniture lava game. Okay. You're going to have your speed plus the speed of whatever medium you're in. Your speed fighting against whatever medium you're in. So in this case, I will off to this side label X, Y. Y is going to be your paddle speed. And what are we paddling in? To a waterfall. So it is not lava. This would be the current of the stream. Okay, so me plus the stream. If the kayaker's speed while... Oh, they're going this way. Okay. It's hard to tell that this waterfall of blood back here is the actual waterfall also. So you are going 4 miles an hour. The current is going 7 miles an hour. Or no, your speed up current is 4. Your speed down current is 7. There we go. Okay. So me with the stream, 7. Me against the stream, 4. What is the kayaker's speed when they're still? Well, it's set up for elimination. I shall eliminate. Shoop. 2x is 11. X is 11 halves, or 5.5. I'm cool with that since it's terminating decimal. Plug it back in and say 5.5 plus y is 7. Subtract. Y is 1.5. But these current problems are set up like that. It's my speed plus the thing's speed, my speed minus the thing's speed, whether I'm going with it or against it. Okay? Think about pushing a car. How many of you had to push your car out or your friend's car out this winter? We only had a couple of snowstorms that were even worth it, but ever done tug of war? Did the big class tug of war or the summer group or whatever it is? Okay, it's me working with this person versus me working against this person. Me pushing uphill versus me pushing downhill. So, others besides 12. Yes, ma'am. 11. I heard a 9 and a 9. Okay. 11, a 9, and a 9. Okay, 11. Moving walkway in an airport, traveler must walk back along the walkway to get the bag he forgot. So, you all know, you've been to the big airports, maybe, where the walkway, it's moving you if you just stand there. If you actually walk along with it, don't you feel like you're just freaking Superman flying down the... Okay? It's kind of a rush. Okay, well, oops. I have to go back along that same walkway. And instead of getting on the other one, you're going to be that moron that goes back against the walkway you're already on and just annoy everyone else on it. So you have the traveler's speed plus the walkway's speed. You have the traveler's speed minus the walkway's speed. Again, define them off to the side. Their ground speed is 2 feet per second against the walkway, so that's minus. 6 feet per second with it. And just like last time, it's set up for elimination. Womp. 2t is 8. T is 4. Go plug it back in. W is 2. Okay. Think about that. 6 feet per second. That ain't bad. Each of these tiles is 1 foot, so it's 1, 2, 3, 4, 5, 6. A second to go from here to here. Yeah, that's fairly fast. Okay. Good old Algebra 1 about 7 years ago. That's actually how I beamed Cora Tobin in the head with a marker, was talking about what this speed looks like in real life. Oops. And I heard a 9. Well, okay. You split $1,500 between 2 savings accounts. Account A and account B. Well, that tells me that the money I put in A and the money I put in B is going to have a total of $1,500. I split $1,500 between the 2 accounts. So they should add up to $1,500. Account A pays 5% interest. Account B pays 4% interest. After 1 year, you've earned this much in interest. Total. We know that totals go at the end. I said I've got account A and account B. Again, label your variables off to the side. But since this total is in money, but more specifically, money interest, I earn this much interest. So the rates that go with it have to be the interest rates to make the interest. The total determines what I'm going to have for my whole equation. It's the label goes here, the label goes all of them. Be careful that you call it 0.04 and 0.05. If you don't remember how decimal percents work from all the way back in first semester, it's always 2 places. If I go decimal to percent, it's 2 places that way. If I go percent to decimal, it's 2 places that way. Zeros as placeholder. And then would you rather do that? I mean, I'm not going to go through it, just time-wise. Would you rather do that by substitution or elimination?
I did by substitution.
Right? It's really easy to get the A and B by themselves in the top equation. Could I also do it by elimination? Multiply the top one by negative 0.4 or negative 0.5, and something just cancels out. I would use my calculator to be careful with my multiplication, though, because you don't want to screw up the 0.4 or 0.5 by 1500. So, okay. I'll just set it up again. I'm going to assume we can do the solving. It's the writing words into math that's our problem, which is why we had a whole section to practice it. Group of scientists studied the effect of a chemical of various strains of bacteria. Strain A started with 6,000 cells, decreased at a rate of 2,000 cells per hour after the chemical was applied. Boy, howdy, did they just tell us exactly what we want. I started with 6,000. I decreased at a rate of 2,000 per hour. Negative 2,000 x plus. Strain B started with 2,000, decreased at a rate of 1,000 per hour. Negative 1,000 is my rate. And then off to the side, you say x is hours because it's so many per hour. Grand total, I'm talking about number of cells. So this many hours, that many cells, x, y. And then y is stuff, y is stuff. Replace y with stuff. I do it by substitution. So, y'all remember how to graph a line? We only spent about a month and a half on them. The last two sections are how I turn systems into graphs when it's not just equals this. Sometimes it's more than equals this. Speaking of words, can you turn those words into equations? Okay. Don't worry about how far we're getting. We're just going to go as far as we can, and then we'll pick it up on Friday. Just don't want to waste a day. Chapter 6, man. Okay. Can you turn those into equations? Or do you recognize special words in there that tell you they're not actually equations? Inequalities. It's right there at the lesson title. Okay. This is a single equation, by the way. It's not a system. No systems today. That comes in section 6.6. Today we got to take a little pit stop and learn how to do a thing before doing systems of them. So one single, turns out it's not an equation. It's an inequality. Okay, but do you see the same setup? You can spend at most 20 bucks. Is that a rate, a starting amount, or a total? Okay, so I got a total of 20 bucks, and if you caught it, at most $20. Case in point, you can have at most, what is it for every other day class? You can have at most 5 absences before you have to pass the final to pass the class. Can you have less than that? Yeah. Can you have exactly that? How I said it, yes. I have to double check if it's at 5 or after 5. Okay. Because most of my classes, most of all the math classes at the high school are every day for a semester, and that's at 10. If it's at most 20, that means I'm going to be less than or equal to. I should make that very obviously a 0, not a 6. And then they gave me 2 different rates, so that's my standard form. They gave me a total. I know I'm going to have something X, something Y. So go find the rates that go with them. If I'm going to have 2 different things with 2 different rates, maybe I should label what those 2 things are. And I will say that it is $250 for a paperback book, and it is $450 for a hardcover book. And I talked about, when we did our standard form back in chapter 5, we talked about how do I graph by intercepts. Graphing by intercepts is when I put a 0 in for y, I will get my x-intercept, right? Everything on the x-axis is x comma 0. So put 0 in for y, divide by 250, was 20 divided by 250? 8. So I'll have an x-intercept of 8. To find the y-intercept, you go put a 0 in for x. Take 20 divided by 450. 4 for 4, 4 for 4, 4, 4 for 4, 4, 4. Yeah. Okay, so 4 and 4 ninths, or 44 ninths. Wait, no. 9, 4, 36, 4, 40 ninths. There we go. So 40 ninths, or y-intercept of about 4.4444444. I can use that for quick graphs. I can put an x-intercept of 8. I can put a y-intercept of 1, 2, 3, 4.4444444. Get a straight edge and connect the dots. Okay. What we're talking about today, and probably finishing next time, is do I have to spend exactly 20 bucks? Could I have just bought one of each and only spent $7? Had some money left over for lunch? So that means everything under that line is also an answer. And if everything under that line is an answer, the way that we're going to do that is we're going to shade it in. It's everything down there. See, what we're doing in kind of a macro aspect here, instead of micro, well, macro means big, micro means small. Okay? So, y'all remember if I said x is less than 4? How do I graph that? Which is why that problem was on our last test, but we only reviewed it, didn't put it on the test. Okay, we're going to have our number line We're going to be at 4. Again, I don't care about labeling the whole thing and making it pretty because the 4 is all I care about. Open or closed circle, which way do I shade?
Open because there's less ink.
Less ink here, less ink there.
You shade this way because the arrow is like an arrow.
And if your variable is on the left, it turns into a little arrow telling you which way you're going to go. So, that. Well, the problem I got is this is now a 2-variable thing. A 2-variable thing means I can't just be on a number line, I got to be on a whole coordinate grid. I'm not just going to shade on a number line, I'm going to shade a whole half of my coordinate plane. Because in addition to that, now I'm going to say, what if y is that? How would I graph that? Closed circle, yep. At 1. More ink here, more ink there. Arrows pointing that way. It says y is greater than 1. Y's are bigger to the right. Or on a coordinate plane, up. So when I smack those two together on a coordinate plane, I get this idea that if I have less ink here, I need a chain of these empty circles. And it's really annoying to try to draw a chain, an infinite chain of empty circles. If I have this, it's really annoying to draw a chain of closed circles. So what's going to happen when I just smack a whole bunch of closed circles together infinitely? It just makes a line. Solid line. If I have a whole bunch of open circles, and I don't want to make a chain like that, instead, I will just use a dotted line. More ink here, more ink there. Less ink here, less ink there. Beyond that, graph the line. Okay? Now, what we're also going to have to do is shade one area or the other, because like this, it's not just a set of answers, it's everything down there is an answer. So we're going to, y'all probably like this one, back to elementary school. Today we gonna color. First, you got to know whether something's actually an answer or not. You got to remember what those Pac-Man, alligator, shark, whatever you learned it as, what does it mean? Is this a solution or not? Now it's not an equal sign. Now it's an inequality. Now it's not one variable, it's 2. So I plug them in. I said y is greater than x minus 3. I said y is greater than x minus 3. They're asking if something's a solution. I'm just going to plug the y and the x in. Plug the y and the x in. And I'm just asking before something's a solution if it makes the equation balance, because it's an equal sign. This side has to equal this side. 5 equals 5. Now, I just want it to be a true statement. 1 minus 3 is negative 2. Is this a true statement? Is 2 greater than negative 2?
Yes.
Yeah. So this is a solution to this inequality. Is negative 7 greater than negative 6? What do you mean? 7's bigger than 6. Right? Think about that number line. That number line, negative 6 is here, negative 7 is there. Negative 7 is not less than. Think about, is it better? And think about money. Is owing your friend $7 better than owing your friend $6? No, I don't want to owe you money. Okay, so no, that one is not a solution. And where this is going towards graphs is, couldn't I pick almost any set of numbers to put in here? Anything that's bigger than that stuff. Could I pick 50 and 1? 1,000 and 1? Could I pick 0 and 1? All of those are going to be solutions. 0 is greater than -2. So if there's all of these things that are solutions, I'm just going to shade everything on that side of the graph. But first you got to tell me, do you even know if it's actually an answer? Because that's how we're going to determine which way to shade. Okay, really don't think about this too hard. Plug in y, plug in x, and you should not need a calculator for that. There is 3 people at this table. What's 2/3 of this table? 2. 2/3 of 3 is 2. 2 plus 4 is 6. Is 6 less than or equal to 6? Because of the word or equal to, yes it is. And that's why when we graph these, we're going to have a solid line if it says or equal to, because things that are on the line can be answers. If it's a dotted line, it means not equal to. So they can't be on the line because those aren't answers. Okay? And they ask me, just basic reasoning question here, if I got y is greater than x plus 10, and something is a solution. Let's say I pick y is 50, x is 2. Or no, sorry, not a solution. Let's say I say y is 2 and x is 50. That's not a solution. Does that mean that it has to be a solution of Pac-Man goes the other way? If 2 is not true, does that mean that it has to be true for this? Can you think of a case where it's not? If it's equal. There's no line there. There's no or equal to. Okay. Well, Logan is not older than his brother. Does that mean he has to be younger than his brother? They could be the same age, and that's very true. Logan, one of my game club geeks, has got a twin brother. Okay. Now, okay, if you want to get technical about it, one came out before the other. Otherwise, mom probably exploded in the attempt. But yes, one is like a couple minutes older than the other. But they got the same birthday, is what I'm saying. Logan Brewer? Yeah. They are fraternal, not identical. They don't look that much alike. Yeah, they're definitely brothers. But if it's equal, that's the one thing that breaks the case. So you got to pay attention to that sign and whether it's got a line or not. Okay, so again, the way that we're going to graph stuff the examples that we're going to use, if I say something like y is less than, I don't know, 1/4 x minus 1. I'm going to graph it just like normal line. I'm still going to have a y-intercept of -1. I'm still going to use my slope of 1/4. Up 1, right 4. Or down 1, left 4. Except the difference is because there's less ink here. Less ink here means less ink there. Instead of doing a whole bunch of open circles, I'm just going to do a dotted line. Less ink here, less ink there. Right? Like kind of looks like a bunch of open circles if you look at the gaps instead. And then I have to decide what to shade. And that's where that example 1 comes into play. You pick a coordinate anywhere on the grid. If I get to pick any number that I want anywhere on here, what would be the easiest one to pick? Even easier than 1s and -1s. 0, 0. The easiest one in the world. I'm going to ask, is this a solution? I'm going to plug 0, 0 in there. Now, if I put a 0 in here, and I put a 0 in here, this just turns into a big fat 0. You see how it's real easy to put in 0, 0. Okay, now I ask, is that true? Is 0 less than -1? Is being broke worse than owing your friend money? No, because if I owe them money, then the first money I get doesn't go to me, it goes to them. This is not true. If that's not true, that means nothing on this side is true. So I'll shade the other way. And I shade everything under that line. That means if I picked any coordinate down there, anything, literally any number that you can think of below this line, it's going to make this true. So I shade half of the graph. Or depending on where your axes are, maybe a third of the graph. Do it again. What if I said y is greater than or equal to 1/4 x minus 1? So now I'm going to still make my points. Start at -1, up 1, right 4, or down 1, left 4. All that's there, same as always. But then, this now says or equal to. It can be on the line. It has more ink. Solid line. Okay, more ink here, more ink there. Less ink here, less ink there. And then ask yourself again, does 0, 0 work? Now, if 0, 0 is on the line itself, don't use it. Pick 1, 0 right next to it. Okay? I'm just using that because it's the easiest set of numbers in the world. If I put a 0 in here and a 0 over there, I get 0 is greater than or equal to 1, -1. Is that true? Yeah! So if that's true, then everything on that side is true. And I shade it. Now, when I say shade it, I mean try not to make it too bad. You don't have to be an artist, but y'all, I see kids year after year, all the way up into pre-calc. Geez, they're it'll look like this. Like that's it. You're not wrong. I mean, I can see where you're shading, but try to put a little more effort into it than that. Okay. You also see which kids murder their paper. Some kids, when they shade in, just blacken the living crap out of it. Okay. So I wasn't about to waste a day, but I'm also not going to assign anything when we're just starting to talk about it. So, yay for you, no homework. I just wanted to get a head start on this because I'm pretty sure 6-6 is going to be like a day and a half kind of thing. So next time we're going to pick up with 6-5, see how far it takes us. Probably go into 6-6, finish 6-6 on Tuesday next week. We'll figure out what to do with that last day. Okay? So yay for you, no homework. You who what?
Can I go to France?